Bountiful oceans are the pride of our planet. But our oceans, which have supported our lives for generations, are now facing serious problems. The fishing industry is suffering many setbacks, including the frequent outbreaks of red tides due to the buildup of sludge from domestic and industrial wastewater, and the environmental impact of organotins from the accumulation of heavy metals. As the removal of harmful sludge from the ocean becomes an urgent issue, problems are also arising between fishery workers and local residents over the removal methods, such as the secondary spread of pollutants and noise from machinery. The Submarine Cleaner, a seabed vacuum cleaner, has been developed in Japan to solve these problems. This machine is expected to have a great effect on the problems surrounding the removal of harmful substances that have accumulated on the seabed in recent years. Remnants of human habitation have accumulated over hundreds of years on the seabed of coastal areas where people live. Sludge builds up due to the influence of domestic and industrial wastewater that flows from rivers. Dormant plankton cell cysts increase and cause frequent red tides, and heavy metals such as organotins that are used in ship hull paints do not dissolve and instead accumulate over many years. These have disturbed the biological system of bivalves and destroyed the biological system of entire fisheries. Hoping to revitalize the fishing industry, in 2002, Japan's Nagasaki Prefectural Industrial Promotion Foundation, a construction company, and Nagasaki University teamed up to launch a big project to develop a machine that removes harmful sludge which accumulates on the seabed. Conventional styles of dredging, which use grabs, backhoes, or pumps to remove sand from the seabed, have many disadvantages. Performing the work causes secondary damage, including the scattering of the accumulated harmful sludge by digging up the seabed, which makes the water turbid and adversely affects surrounding areas such as fish farms, and loud noise from the machinery that makes nearby residents feel uncomfortable. Repeated indoor experiments and trial and error were performed at Nagasaki University in order to solve these problems, taking 6 years from the original conception. Then, finally, the prototype of the Submarine Cleaner was completed in 2008. When the Submarine Cleaner reaches the seabed, water is expelled like a jet engine, and the mud is drawn up inside the cleaner. Approximately 25 centimeters of sand from the seabed surface is stirred and lifted. By drawing up the fine particles of silt and sand in the mud, it is possible to dredge a thin 10-centimeter layer from the surface, which contains most of the harmful sludge. As a result, the large stones and heavier sand which are not drawn up remain on the seabed, making it possible to remove the mud that floats easily, which was impossible with conventional methods. Because the mud that is drawn up does not leak out of the cleaner at all during this process, the sea does not become turbid, and the secondary spread of the harmful sludge does not occur. In addition, a treatment method for harmful sludge to process the drawn-up mud was jointly developed with Kyushu University. The best of Japan's latest technology was gathered to devise a mechanism for processing the mud according to the pollution level of the harmful sludge. This onshore processing can flexibly respond to the properties of the mud and sand that is removed and the size of the processing area. Therefore, cost reduction and the creation of local employment can be expected due to collaboration with companies in other countries. The Submarine Cleaner has 4 advantages. The first is that cleaning can be performed without making the sea turbid. By making it possible to draw up the mud containing harmful sludge without secondary spread, it does not affect nearby fish farms, and there is no need to stop free-dive fishing. Fish can even swim peacefully right next to the unit while it is in operation. This is a scene that was unimaginable using conventional methods. The second advantage is the simplification of the operation process. Since there is no turbidity, anti-pollution films are not required, thereby reducing costs. Also, the ratio of mud contained in the drawn-up water is 60%. Removing only fine dirt is possible, leaving heavy sand and large stones as they are. By reducing the amount of excess sand and sediment that has been difficult to process until now, the formerly necessary large landfill site becomes unnecessary. Also, dredgers such as grab ships generally move on the sea. But since the submarine cleaner can be disassembled, it can be transported in a container that is easy to arrange and move, thereby reducing costs. The third advantage is that fast performance is possible. The sense of stability is improved by having a suspension frame on the main unit. And furthermore, the weight of the main unit can be reduced by adjusting the buoyancy with the attached ballast tank, making it possible to handle soft seabeds. As a result, smooth sliding operation is possible even on uneven seabeds. The device's capacity is up to 3,000 square meters per day. The fourth advantage is visualization of the operations through Information and Communication Technology, or ICT. The system, called RTK GNSS, involves attaching a GNSS to the crane ship to identify the ship's direction. And cooperation with an onshore base station allows accurate measurement with an error of 2 centimeters in position and 5 centimeters in depth. The next operating instruction is given while confirming this information on a tablet in real time, which makes the work more efficient. In addition, because the depth can also be measured, there is no irregularity in the depth due to overdigging, which suppresses the occurrence of the blue tide that is said to be caused by troughs. These 4 advantages have resulted in significant cost reductions. If only a thin layer of the surface is dredged, the operating efficiency of the large cleaner is US $4.10 per square meter. On the basis of a 1,000 square meter area, this saves US $939 compared to pump dredging, and US $11,129 compared to grab dredging. Mr. Yamanaka, head of the Hirado City Fishery Cooperative Association in Nagasaki Prefecture, where the submarine cleaner has actually been used, has said the following. I was worried since abalone fishing, free diving fishing, and fixed net fishing would be affected if turbidity appears. But the work performed with the submarine cleaner last year did not cause any turbidity or noise at all, so there were no complaints during the work. The submarine cleaner comes in 3 types with differing sizes and functions. The first is the large cleaner, which is suitable for removing harmful sludge such as fine silt by drawing up only 10 centimeters of mud from the seabed. An intermediate frame can be attached, which makes operation possible at a maximum depth of 100 meters. The second type is the middle cleaner, which is suitable for dredging sand and mud by digging deeper underwater. It can be attached to the bow of a small boat, such as a diving boat, which allows work to be performed even in narrow fishing ports such as Komoda Port and Tamanoura Port in Nagasaki. The submarine cleaner has been used in many projects in Japan since 2009 and has produced good results. For example, Silt was removed during the 2009 Hakata Port sludge removal project in Fukuoka Prefecture. By using the cleaner on the mud-filled seabed, the seabed was tilled, leaving behind clean sand and white shells. The submarine cleaner can also reduce sulfide deposits on the seabed by 72%. In a demonstration project to improve seabed condition as a countermeasure against red tide, which was conducted in Nagashima Town, Izumi District of Kagoshima Prefecture in the 2011 fiscal year, dormant cells, which are called plankton cysts and are said to be the cause of red tide, were removed. This project achieved a cyst removal rate of up to 82%, and no red tides occurred after that. The middle cleaner was used in the 2014 fiscal year at Tamanoura Port in Nagasaki Prefecture to neatly remove sand that had accumulated at the wharf's seabed to secure water depth without moving the rocks on the seabed. The submarine cleaner's breakthrough technology has received various awards, including the Excellence Award at the First Fisheries Infrastructure Development Sector Awards, sponsored by the Japan Fisheries Agency, and the Excellence Award at the 13th National Technology Development Sector Awards, sponsored by the Ministry of Land, Infrastructure, Transport, and Tourism, and is starting to be praised from all directions. It is also attracting attention in other countries beyond the sea. We have appeared on the Vietnam government's website, and a briefing session has been held in Korea, and we are receiving a large number of inquiries, said Mr. Suenaga, the submarine cleaner's developer, when asked about future developments. The pollution that Japan experienced is starting to occur in developing countries, which is something I want to address. In the future, the submarine cleaner is also expected to be effective in the removal of arsenic that has flowed from volcanic eruptions and the removal of microplastics from the ocean, which is a global marine environmental problem. The big project to clean the ocean's seabeds may have just begun.